Today's agenda is I will be briefing about the environment of SAP HANA, how its architecture is laid on, and the key benefits of SAP HANA as a backend database system, the differences between other traditional database systems that you are aware of with these HANA database systems. I'll discuss about few test cases which will come handy while determining whether you are choosing SAP HANA or traditional databases. We will specifically discuss few of the features that comes with SAP HANA, like column store index, row-based storage. All these are new to the environment, the multiple engines, and the rest of the new features. And also, after a small demo, we will discuss about some of the limitations that HANA comes with. SAP HANA, short for High Performance Analytic Appliance, is an in-memory column-oriented relational database management system developed by SAP. An in-memory database means all the data stored in the memory, that is RAM. So there will be no time wasted in loading the data from hard disk to RAM, or there will be no time wasted while processing the data, as there is no action on persistent storage takes place during the data processing. Everything is in memory all the time, which gives the CPU quick access of data for processing. Hence, SAP HANA is best suited for retrieving data from it and is read-optimized database platform. The speed advantages offered by this RAM storage are further accelerated by the use of multi-core CPUs, multiple CPUs per board, and multiple boards per server appliance. Complex calculations on data are not carried out in the application layer but are moved to the database. The ad hoc analysis can be performed directly inside the SAP HANA database, as everything is in memory, and real-time execution of data can be performed, which is way faster than the traditional databases. It is designed to handle high volumes of data, and therefore this is the best choice if you are dealing with an analytic product. SAP HANA is equipped with multi-engine query processing environment, which supports relational as well as graphical and text data with the same system. It provides features that supports significant processing speed, handle huge data sizes, and text mining capabilities. SAP HANA database consists of multiple servers, and most important component is the index server. SAP HANA database consists of index server, name server, statistical server, preprocessor server, and access engine, which I'll discuss. So when you send request to SAP HANA, it first hits the HANA distributed environment channel, which in turn sends the request directly to the index server, as shown in the figure. The other servers associated with HANA Engine is specifically dealing with the special use cases, which we will discuss later on. Now, looking at the index server, or rather a cluster of servers in the distributed environment, the request once received will try to find a transaction for that particular session. So in this case, the transaction manager is working on. The transaction manager hands over the transaction ID, which is present in the context, or otherwise builds it on the fly and keeps it as a reference. In parallel to this, the server also checks the validity of the connection and also checks the connection availability or the session availability of, and also authentication modules. Once this is done, the query is sent to the SQL parser environment or the planning engine. The planning engine will create the data plan for the SQL statement. It decomposes the query into separate tokens, which are then validated before creating the actual plan. This part can also communicate with the preprocessor server for textual data information, the statistical server to update the stats of the current query execution, etc. Once the SQL plan is generated, the plan is executed by the SQL engine. The SQL engine will enable the HANA environment to actually fetch record from data repository. As I have already told you, the data in HANA resides in memory totally. So the SQL data engine looks into the data in memory always. As we also understand that the data engine can perform tasks in parallel, so the query plan which is passed will be executed in parallel and the result will be aggregated and returned back. So if there is a complex calculation, the threading model will ensure better throughput on the query. There is a separate scheduler available which takes care of the repository and updates the delta changes to the hard disk. Hard disk is mainly the persistent layer. So that to ensure that the data when changed on the repository persists on the disk drive as well, so that any sudden crash on the server does not lose the data permanently. The data update is also triggered by committing the data changes into the repository. As I've told you, most of the heavy lifting of application queries are being handled by the index server. It forms the mandatory server of the HANA environment. The HANA provides you with strict hardware requirement guidelines for installing the index server. The index server mainly deals with the actual data that is being processed. It also has a scheduler which automatically gets triggered either by default at 5 minutes interval or at the commitment of any transaction. The default time interval can be changed through the global.ini file which resides inside the index server. Remember, you need to restart the HANA server to take that default configuration change into effect. So the scheduler takes care of porting the data from memory location to the persistent storage location. It does not does the same thing for logs as well. The index server, as stated, contains a processing engine which processes and validates the SQLs and MDX query. MDX means multi-dimensional queries, which are used by OLAP multi-dimensional queues. So after authentication of the context, it loads the transaction. So in the figure, this is the architectural diagram of that you can see for the index server. After receiving the SQL from external environment, either through the SAP client SDK or through direct SQL invocation, the connection and session manager takes care of the authentication mechanism. Once the connection is authenticated, the session is created, the request is sent to the request processing engine. Here all the components responsible for doing heavy lifting of the query is done. There is a SQL processor which lets the engine call the SQL script or MDX script component to parse the SQL queries and the call to the planning engine to create a plan for the data. Once the plan is generated, it passes the plan to the relational engine. You can see in the diagram there are two kinds of data present in the environment. Which one is the row stored data and another is the column store. So according to the plan, it takes into count all these data types and loads the appropriate data to the processing. The SQL processor receives the pointers to the loaded data and calls the calc engine if there is any complex calculation required to be performed. The aggregation of data and or any calculation is performed parallelly, as the HANA environment supports multiple engines for parallel processing. The result is taken back from the calculation engine and then aggregated and returned back to the user as depicted in the figure. There are two extra portions like persistent layer which we have already discussed, takes care of the transaction data updates and the transaction log updates and stores it into the persistent. HANA efficiently chooses when to write to the disk such that even uncommitted transaction state is also maintained. Now coming to the components, if we recap what we have already discussed, the persistent layer ensures durability and atomicity of transaction performed in the environment. The transactions once committed will automatically taken care by the persistent layer to update the same on the disk drive to ensure that the data is durable even if there is any disaster situation on the environment. The data stored in the disk drives will be loaded into memory again after the HANA environment is restarted. The persistent storage also takes care of transaction logs. It will write logs if the transaction is committed or completely undone. The transaction log keeps tracks of auditing reports as well, just like other traditional databases. So through them, you can also retrieve what kind of data is changed and the old values of the changed data. The relational engine is responsible for determining the relationship of the tables and storage types. It allows to retrieve the actual data, determining the type of the storage on request. It will also handle how data is getting stored when it is requested to change. As there are two types of storage, one is row store, and where the contiguous location is used to storing the entire row of data, just like the traditional DBs. And there is a new feature called column store, where the columns are stored in a continuous. The connection and session manager section is responsible for handling authentication of the user that is used to perform the operation. When a request is made, this component will check whether the user ID and password is correct or not, and if there is a success, it will generate a session for him. When the session is generated, the component also puts some parameter which says whether there is an auto commit enabled for every operation performed in the session. It takes care of current transactions, so if there is any new transaction for a particular user, the transaction ID is stored into the current session. The isolation level for which the user, which helps the engine to perform correct operation for the session, etc. There are two ways of authentication. One is using user ID and password, or there is another way which is HANA database authentication, or even there are external authentication providers like OLEDB, ODBC, JDBC, etc. The whole authentication system is handled by this section only. Authorization management. As the name suggests, the authorization manager is responsible for checking the privileges of the user who is performing the operation. When a request is made by the user, the authorization manager will check whether the user have correct rights to access the specific type of operation, or not even the specific data object or not. The authorization manager is also responsible for assigning or granting permission to the objects. Authorization manager can also grant an user a dimension attribute which tells the user whether the user is restricted to one dimension or how many. For instance, if you are working with a cube, you might require 2 or 3 dimensions to get analytics for a particular task. Planning engine, as the name suggests, it actually requires to generate actual SQL processing plan. The planning engine will generate plan for a particular request, such as if the request requires 2 or more data objects, it generates a plan on how to load those data objects efficiently and passes the plan directly to the relational engine. As mentioned in example, during New Year, the planning engine might request to shadow copy the actual data object to multiple locations after applying filters, such that the filters are not performed every time there is a request for the same data. The engine keeps track of all the requests being made and hence does optimizations if the same filter is applied for a considerable number of times. While generating plan, the planning engine also takes care of the count of different levels of aggregation. This means, let's say you have to create cumulative sum of all the products for all vendors. The planning engine will generate plan on how to parallelize the aggregation to optimize the performance. The calc engine is taking care of all the calculations that needs to be performed to generate the result. It receives the domain specific objects and creates a separate calculation model which is used to restore the result after performing calculation on these models. The calculation engine works parallelly but keeps track of all threads that is running on the environment to perform calculation. The calc engine is also responsible for accuracy of data that is returned back to the SQL processor. Analysis of textual data is sometimes very important. If a query is made which requires textual data search, either using wildcard or using pattern, the index server makes use of the preprocessor server, which receives the text search request and returns back proper information about the data that needs to be retrieved. The preprocessor server is only used when there is a text search analysis needs to be performed. Now coming to the name server. The name server is responsible of keeping track of the entire system landscape information. For a distributed environment, it keeps track of all the systems that are installed in the environment. It keeps track of the configuration and the network topology, means the IP address, MAC address, etc. The name server also keeps track of the data blocks loaded in the index server. Thus, the environment uses name server to determine which index server have the data loaded, and it redirects the request to that only. This ensures decreased requirement of reindexing of data inside the index server, and it improves performance. Coming to the statistical server is responsible to checking health of each and every component of the servers present in the HANA environment. It keeps track of the resource allocation, consumption, statistics on bandwidth usage, etc. It also keeps track of the overall health and the performance of the historical data is stored into the server, can be used for analysis purpose. When the systems are not responding or having some issues, it can generate some alerts. The statistical server can give you vital information about the health and the cause of the problem, if there is any, during the disaster recovery. Okay, now let's talk about some of the benefits of SAP HANA. First of all, HANA is best suited for OLAP queries. It is based with analytics. Hence, if you are working with data to get some business intelligence, it is the best data platform to work with. It is the best inbreed in memory data computing. There are other memory databases, memory-oriented databases rather, as well, but they are either doing it in partial or they are not at par with SAP HANA. HANA have a great management console to work with, so business users can also use this tool to get analytic data. As it works in memory, it is said to be 3600 times faster than traditional databases. The memory really works very fast, and it is taking advantage of the same. By memory, I mean the RAM. It is popular because it is built by SAP. There is a high level of optimizations made on the database when it works with SAP ERP. So it's a really popular choice there. There is cloud-hosted SAP HANA available, which can be used as pay-per-use basis. Another important point is HANA uses RAM memory optimized. It stores data in compressed format, and hence it reduces space requirements. Now let us differentiate between HANA and traditional databases. The first point indicates as we have already discussed, HANA uses RAM to hold the entire database. So if the size of the database is 1 TB, the amount of RAM required is also 1 TB. So HANA works entirely in memory, while most of the traditional database stores or retrieves the data from disk drives. Other databases like Oracle, SQL Server do come with in-memory data, but they are architected in such a way that they do not inherently optimize for in-memory data usage. Hence, for those databases, if you are using in-memory concept, there might be partial data available in memory, while the rest is retrieved from these drives. Column store ensures that the data in the column is stored in contiguous blocks, which is in contrast with the row-based storage. HANA supports both type of data storage, while traditional databases are still following the row-based data storage. For analytic purpose, if column storage data is used and it is stored in contiguous block, it helps in better performance. HANA, as it runs in memory, is very flexible for processing things in parallel. Your data and calculations are all performed in parallel for a single request, which later be aggregated and returned back. But traditional databases are still sequential. OLAP or online analytical processing queries are performing multidimensional analysis of business data performed based with HANA as it is in memory. While for traditional database, it takes huge time to load the data for different dimensions before producing actual analytics. As for OLAP, the performance is automatic because of its architecture, while performance for traditional databases is gained by denormalizing of data, which in turn increases redundancy. Now, let us talk about some of the use cases where HANA can be a perfect choice. For sales reporting, CRM, it quickly identifies top customers and product by channel with real-time sales reporting. It improves the fulfillment rate and acceleration. So, in case if you are using a CRM solution, HANA can be a choice. It can give you the key performance matrices of the billing, credit, memo. You can analyze those and get reports. There is another solution use case which can be a financial reporting service where it can obtain immediate insights across your business into review. Accounts payable, receivable, open and overdue items will be shown as a graph, let's say, and it works very fast in HANA. There might be a shipping reporting requirement where HANA can be a choice because it works with real time. So any shipping will automatically update the real time data and it can be updated in your reports automatically. There could be a use case of purchase reporting where if there is any purchase going on in your organization, you can quickly get that that reported in your system, or you can also create an alert depending on your choice. Master data reporting can also be one of the use case for HANA environment. Now let's talk about the different storage options. All columnar storage is stored in contiguous locations. As contiguous locations are column specific, the reading of data is very fast. There is lesser data conversion requirement, and all the unprojected columns can be stripped down before loading it into memory. On the other hand, for row storage, it is write optimized, as insert and updates will work better. But for reading data, it needs to go through or traverse all the columns of a particular row to determine only the projected values. The schema needs to be read to determine the data type of each data in contiguous location, which makes it even slower. So that is the basic difference between the column store and the row store database system. In case of HANA, we have both options. So depends on what your choice is. You can choose either column store or the row store. Now there is a concept of multiple engines. HANA provides multiple engines inside it. So any request made to HANA platform optimizes the utilization of CPU cores to increase the throughput and reducing the execution time. The SQL and OLAP engines are also separated in case of HANA, and hence they are optimized per the type of the data. In case of HANA request, it is broken into multiple pieces, and the same is sent to the engine for processing. The SQL processing engine acts as a controller which retrieves data from each of these engines, parses it and aggregates to get the actual result. The actual result is then returned back to the requester. So HANA is mainly important if you are using OLAP reporting tools to fetch data in real time and show it in to the user. Let's now look at the demo, and let's look at how. So this is an environment where I have installed HANA. This is not the environment where I installed HANA. As I have told you that HANA requires uh, Linux, SUSE Linux. So there is another environment which is connected to this machine, which has HANA database installed. Now this is the administration console, where you can actually get to know what kind of data you can store. So this is my DB server. This machine is connected to the DB server. So if you want to add another server, you can add the host IP, instance number. You can actually describe all this, and it will be connected. There is a system monitor which will tell you what kind of service are not running, or what kind of service you need to restart, all these things. There are few tools, administration tools as well, which will help you. There is a SQL console. So if you open this, it will open the SQL console. As you can see that it says HANA 00, which means that there is a database which is named as HANA 00. So let's see the catalog. So there is a database called HANA, which is DB1, which is hosted in DB1. So I can query to that database. Now these are all the databases. As with the other database systems, there is a common database where you should run the database creation scripts. As I have told you that for every session created for HANA, there is some kind of properties that that is maintained for your connection. So these are the properties. So auto commit is by default on, but you can set it off if you don't want it. There are client distribution levels which you can also turn on or off. There is isolation levels. If read committed, then it will only read the data which is committed. But if it is repeatable read, then it also read uncommitted data. So these are few things that you can set it up while running your SQL in the console. So now let us create a database. As I have told you, to create a database, you should log into that common database, and you should open the SQL console from there. So to create a database, I will just paste this script. So in case of HANA, the syntax is like this: create schema APPSeCONNECT. APPSeCONNECT is the name of the database, and owned by system. System is the user. So system will be the user of, will be the owner of the APPSeCONNECT database. So if I run this, to run this, you have to click either this button, or you can press F8. So let's click here. So you can just see how fast it has been to create a database, which is not the case with any other database system, because in this case it created the database on the fly in memory, and there is another scheduler which works in background, which will take this data and write it back to the database files. So let's refresh this. So you can see that how quick the refresh occurs. So there are a few sections in here. One is functions, indexes. So these are all concepts of database which you can work here as well. There are procedures. There are table types. Table types are the special type that you can define on the database, which you can assign to a procedure, and where you can return that data using that type. So it's a complex object, complex table, which you can use as a result of a procedure. There are sequences like Oracle, so you can create sequences to create a sequence of data. Synonyms, there are tables, so this is the main area where we will work on. So let's create a table. So to create a table, it's very simple. So there are two kinds of tables, as I've told you, which is available here. So let's just go to this APPSeCONNECT database. Now, if I see the table structure, so I said that create column table company, which has two fields, one is ID and another is name. So basically the company will be a table which is columnar table. So all the IDs will be stored in contiguous blocks and all the names will be stored in contiguous blocks. So if I run this, so it says it successfully created that table. Now if I refresh this one, so you can see there is a table created. So if you just open the definition of this table, you will see there is two columns. I can create another column from here as well. So there are further properties as well. So you can use. Let me try to create from design as well. So if I want to do the same thing in design mode, so I'll say new table, and there I have to type the name of the table. Let's say APPSeCONNECT logs. So the schema will be APPSeCONNECT, and here you can see there are three options available. One is the row store, another is the column store, and the table type. As I have told you, table type is for the temporary tables which can be returned by a procedure. So if you create a table type kind of thing, let's say ID and let's say age, I will make it a small int and this 100. So this is a table type kind of table. So if I execute this, this will be created, not here. This will be not created here. This will be created here. You can see it here. So if I go to the database console and I write insert into values and say ID 1, age 10. Now this will not work because you cannot insert a value in a table type temporary tables. So table type will allow you only insert if it is inside a stored procedure. Okay. Similar to this, I can create a table with row storage, which is basically same as you do with SQL Server or other databases. And if I run this, it is created. So if you see this, I refresh, so company 2 is created. And similar to this, you can have insert statement, update statement. So if I insert some values, so I will say company, so it will insert both the values together. So as you can see, the semicolon will indicate that it is a new record that is being inserted. So if I open this, you can see both the data is created. As I told you that these kind of things you can also do it without using this administration console. It supports the SAP client library as well as it supports ODBC, OADB, and other drivers. So you can use any of the drivers to access these databases. So it will be only a connection string that you will be using to create these tables. So let's come to the procedure. Let me see if there is any procedure or not. So I can just show you the syntax of a procedure. So if I open the definition, no, sorry. Just a minute. Oh, these are table types. Just a minute. So let's say I open. So I have actually installed SAP as well. So these are the databases that are created for SAP. SAP. So let's see if there is any stored procedure or not. Okay. So this is a stored procedure. So you can see the syntax: create procedure, and you need to use quotation to actually define the stored procedure. The name of the stored procedure is this, which outputs varchar of 270 characters and another output of another 270 characters. And there are two select statement which gets you some data from this stored procedure. Same thing happens with the functions as well. So if I open a function, oh, I don't have any function. Okay, so same thing works with functions as well. So now coming back to the presentation. Sorry. So now let's talk about some of the limitations of using SAP HANA database. As the first point says, it is too expensive. The cost ranges between $1701.89 to $3,000 per month, which is really expensive as compared to other databases. But when you actually check, the licensing is based on the CPU cores. Also, it is very resource hungry, and hence you need to maintain huge infrastructure for it. Even if you are hosting it in cloud, you might end up spending too much of money. So in short, SAP HANA is very much expensive. SAP HANA, it is not recommended to use HANA for huge data, because the purpose of HANA is something different. According to specs, if the database is over 16 terabyte, it is not recommended. You can go with partial HANA with partial other databases, such that you use HANA only for analytics, and for data storage you use any other alternatives. SAP HANA, as I've said, is very strict on the system requirements. You would see there is a huge amount of RAM required to install HANA. There is a huge amount of hard disk, a huge amount of CPU power. So all these are required to actually install a HANA environment on your premise. It also requires the SUSE Linux to be installed, because HANA does not work in any other operating systems other than SUSE Linux. So it is optimized for SUSE Linux. So you need to actually install SUSE Linux on your environment before actually installing HANA. And it makes it very strict as per hardware or software requirement. There is no way to migrate the data to standard RDBMS. I am not sure if there is any tool available or not. If so, I am not sure whether it works smoothly or not. I would mark this as a limitation. There is no point-in-time recovery available as per the current stage is concerned. So if there is any problem in the database, there is any data being migrated on the databases which you don't want to keep, and you want to restore it back to a certain point or at a certain time, you actually cannot do that. This for other databases, these are a common scenarios, and you can use the transaction manager to actually return back to a particular recovery point. But in case of HANA, there is no option available right now. But I'm sure HANA is working on these limitations, and hopefully we will come with these very soon. That's the end of my session. So if you have any query, you can ask me right now.
Yeah, thanks Abhishek for the presentation. Abhishek, able to hear me?
Yeah. Thank you, Subhajit.
Yeah.
Yeah, I can
So
hear you.
basically, yeah, I have already received several questions, so I'd like to just mention those here. So first question is, can HANA run on Windows environment?
No, as I've told you that HANA is a very strict requirement. So it requires SUSE Linux to install HANA. But one thing you can do, you can install HANA database in your SUSE Linux, and in your network you can have an Windows environment, and from where you can install the management console, which is available for Windows as well, as I showed you in the demo, and you can use HANA from there. But according to the specification, currently HANA does not work in any other environment other than SUSE Linux.
Okay. So I'd like to request all the attendees to, write their questions in the questions pane, which is available in the GoToWebinar console. So you can see there is a question pane. Kindly write it down there, and we'll try to answer as much as possible. So a few other questions. Is there any limitation on HANA if it used in cloud?
No, not currently. There is no limitation. You can use it in cloud. But as I've told you that HANA is very resource hungry, so you might have to bear a lot of money to use it in cloud. But in case if you are using in cloud, you will get all the benefits of the cloud environment, like scalability, reliability, pay as you go. All these things are available.
Okay. Another question is, one of my customer use SAP Business One with SQL database size of around 75 GB, 75 gigabytes. Will using HANA be a benefit to them?
Of course, because for 75 GB database, it's highly recommended to move it to HANA, because HANA is works in real time. So anything below 16 terabyte, it's always recommended to go with HANA, because you will get a lot of performance there. So if you are retrieving data very often, or if you have any third-party application which connects to your SAP B1 to get data, so you will see considerable amount of performance gain when you actually go to HANA database.
Okay. Next question is, can HANA be used as an integration tool to SAP B1 read write in database? We currently use B1 WS with DI server, and it's horrible.
No, no, HANA is actually the backend database system. So basically, it doesn't work as an integration platform. But if you are seeing our profile, we actually integrate the data between SAP B1 and other applications. So you can give it a try if you want. But HANA is actually for data storage purpose. It's not related to integration platforms.
And to add some more words to that answer, so when we connect to SAP B1, which is using on HANA database, so we use service layer, because DI server is often not available in cloud environment where HANA is hosted. So you can try it out. You can try service layer to connect to HANA, and service layer can be the integration component.
Exactly.
The next question is, what is cost of HANA, both cloud and on-premise, in US dollar per user?
So the license cost, as I mentioned, it is around $3,000. So it's per CPU cost of HANA license. Uh, but using the HANA cloud, I think there will be some benefit because it will be pay per use. But it entirely depends on the configuration that you choose. So what we can do, I can quickly search, or I can.
Abhishek, we do
Yeah.
not, we have a lot of questions, so we
Yes, yes,
can
yes. Okay.
get back with the answer later on, because we will send all the question answer as well as the video recording of this presentation and the slide. So there we'll try to answer this. Next
Yes.
question is, do you,
Basically the
yeah.
price. Basically the pricing, you can just quickly Google it, and you will get the pricing details.
Next question is, do you know, is the SAP Business One application extensively rewritten for HANA, or is it just the database migration?
Uh, Actually, SAP Business One, there is some optimization present in HANA which uh, give you better performance when working with SAP Business One. But SAP Business One is not rewritten. Rather, HANA is having those optimizations.
Okay, next question is, what is the minimum RAM for HANA?
Okay, according to specification, I also have to check actually. The system requirement I have to check. Let me check.
Okay, in the meantime, I will just, ask the next question.
Yes.
So, can I run SAP Business One on SQL Server or Oracle and use HANA for reporting or data analytics?
Uh, yeah, obviously, because HANA is based for data analytics. So you can use HANA for only the data analytics, and use Oracle for your other database storage. That's perfectly fine.
Okay. So the next question is, will there
Yes.
any SAP HANA installation? Okay, will there be any SAP HANA installation webinar be organized in future? So we'll try to organize more webinars around SAP HANA for sure. Uh, Next question is, brief some new features of HANA 2 versus HANA 1. So Srinivas asked this question. So Srinivas, we already posted a blog on HANA 2. What's new in HANA 2? So you can just go and check our blog section at our website, appseconnect.com. So there you will see a latest blog which we have posted on HANA 2. So there also we have briefed that what's new that came up in HANA 2 which was not present in HANA 1. So we'll just skip this question. I guess Srinivas, you can go and check our blog. Uh,
So yeah,
Next question is, yeah,
on the question about the minimum requirement
RAM.
of RAM, it's actually
Yes.
64 GB minimum.
Okay.
But it
Okay.
works well with beyond 9400 MB.
Okay. Thanks, Abhishek. So next question is, what is the impact of using linked server in HANA projects?
uh, Linked server, in the sense, I mean, you want to create a linked server, and you want to connect the data with HANA, with to the linked server. Is that what you mean?
I guess so.
Yeah. So basically, there are a few tools which actually get the data from the linked server to the HANA. So if you are using linked server to create analytics on the HANA environment, you can do that. Actually. So there are specific blogs on them created by SAP to create a storage area and an analytic area using linked server.
Okay. Next question is, as you said, it can be only loaded on SUSE Linux, but in our company it is loaded on Red Hat Enterprise Linux as well.
Yes, yes. Red Hat came up very lately, so it's pretty new. I mean, it has a support available with HANA 2, I think. But before that, if you see the documentation, it opens up with SUSE Linux first.
Okay,
So it
okay,
currently you can also install it in Red Hat.
okay. So another, uh, so a big question. We are using SAP Business One on HANA with multiple SAP patches. We are facing problems with HANA drivers 32 and 64-bit. Sometimes if we install 32-bit of one HANA revision and 64-bit of another revision, 32-bit driver will not connect and says default driver not specified. Is there any solution for this?
Okay, so basically, if you have installed the 32-bit, I think you should only install the 32-bit drivers, because you cannot work both ways. So either you have to go with 32-bit or a 64-bit. It's preferable to use 64-bit HANA environment, because you will get a lot of memory optimization using 64-bit. But HANA can be installed in 32-bit as well. So you should either go with 64 or 32. You don't
Okay.
you shouldn't be mixing them together.
Another question is why HANA is using case sensitive in SQL console.
Yeah, this is something that that is there from the initial release. But if you noticed in our environment, I can actually call it without case sensitive, because the latest patch that is available with HANA, it does not have that case sensitivity. So you can even configure that. If you want case sensitivity, you can configure the database with case sensitive. But by default, it will not be case sensitive. So I can say create table X Y Z. It's perfectly
Okay.
fine, and I can call it in uppercase as well.
Another question is there any consequences if database size is more than 16 TB, 16 terabyte?
Yeah, of course, because HANA is basically suited for real-time operation. So if you have a database more than 16 TB, I think you should think twice, because uh, you might be installing a lot of RAM to use this 16-bit TB storage. Because in case of HANA, all the data that is residing inside the database will be loaded into RAM when it starts up. So basically, you are not using the database, the secondary storage much. Rather, secondary storage in case of HANA is only for disaster recovery situation. So if you have any crash in the server, you might want to restart the HANA database to get the data available from your secondary storage. But if you have a database size, let's say more than 16 TB, I would not recommend to use HANA.
Okay, okay.
Yeah.
So for now, these are the questions. So if you have any other question, we'll wait for some time. But I guess we are about to end the session. Uh, Another question is point in point in time memory refers to snapshot kind of. Provide some glance on it.
Point in time memory means, as I have told you, that it is already in the memory. I mean, if any data that is there in uh, the database is first loaded into memory. So when there is any change in the memory location in the repository of the RAM, there is a scheduler which actually takes the snapshot of that particular change, and it does a delta update to the secondary storage. So that is called a point in time memory location where there is a change.
Okay. Another question is there any configuration for case sensitivity? So any configuration changes need to be done so that, HANA SQL console can accept both uppercase and lowercase letters.
Exactly. I think there is a configuration option. Uh, what I can do, I can give you that configuration over mail or something. Would it work?
Yeah, Abhishek. So we have all the questions available here with the user. So later on, we can answer few questions
Yes.
over email as well.
Basically, if you have patched your server with the latest update of SAP HANA, you would be already getting the default behavior as case insensitive. But there is a configuration option which you can just run that query and it will be case sensitive again.
Okay, so we'll take the last question and we'll end the session here because we are about to run out of time. Why sequence of data changing in dynamic tables in HANA?
Sequence of data is changing. I'm not sure whether it does, but in our case, whatever I see, it doesn't because actually there might be one case if you are using columnar storage. If you are put inserting a data in between, it might actually uh, create a memory location inside that memory which will have a sequential change on the data, but that won't be permanent because if you restart your HANA server, I think the sequence will be turned back to normal. If it doesn't, what we can do, I can give a research on that, and I can get back to you if there is any issue with HANA sequencing.
Okay. So, we are still getting a lot of questions on case sensitive configuration. So we will check on that and we'll reply back on the email, which we'll
Yeah,
send to you along with the video link and presentation link of the webinar. So definitely we'll get back to you with the, configuration of case sensitivity in SQL console of HANA. But, time the time is over now. So we'd like to close the session. We'd like to wrap up the session for today. So definitely in future we'll organize more webinar on SAP HANA and we'll showcase and we'll give you more insights around this technology. Thank you all for participating in the webinar and wish you a nice evening or have a nice day ahead. Thanks. Bye.
thank you all. Bye.